What do you, Somi sir?
Sir, you are muted.
Okay. Good evening, dear participants and my dear colleagues. It is my great honor and privilege to welcome you all to this third session of ATAL Online 60 Faculty Development Program 2025 on building the next wave of Indian startups with advanced computing technologies. Today, we are greatly honored to have with us our esteemed speaker, Professor Debashis, Professor Department of CSE MAKAUT, who will enlighten and enrich us with his valuable talk on the impact of quantum computing on various industries. As we know, quantum computing, it is a revolutionary technology today, leveraging the principles of quantum mechanics, is poised to transform industries by solving complex problems far beyond the capabilities of classical computers. Its potential impact spans a wide range of fields from healthcare to finance to logistics and material science. By enabling breakthroughs such as drug discovery, optimized supply chains, and advanced cryptography, quantum computing promises to redefine innovation and efficiency. As industries prepare for this paradigm shift, they face both opportunities and challenges in adopting and integrating this groundbreaking technology. So, as we sought to shed a more light on this topic and to give us a more ideas regarding this topic, we are most privileged to have our respected speaker, Professor Debashis from the Department of CSE MAKAUT. And now I take this privilege to introduce our respected speaker. Debashis sir is a professor in the Computer Department of Computer Science and Engineering at the MAKAUT, West Bengal, India. He received MTech from the University of Calcutta in 2002 and a PhD from Jadavpur University in 2005. He is a senior member IEEE, fellow IETE, and life member CSI. He was awarded the prestigious Voicast Fellowship by the Department of Science and Technology, Government of India, to work at the Heriot-Watt University, Scotland, UK. He received the Endeavour Fellowship Award from 2008 to 2009 by BEST Australia to work at the University of Western Australia. He received the Young Scientist Award in the year 2005 at New Delhi and in 2011 in Istanbul, Turkey, from the International Union of Radio Science, Belgium. In 2016, he received the J.C. Bose Research Award from IETE, New Delhi. In 2019, he received the Shiksha Ratna Award from the Government of West Bengal. He published in 400 journals and 200 conference papers, 20 books, and granted 4 patents. He has projects sponsored by AICTE, UGC, WBDST, DST, WBDST, World Bank, AWS, and MITY. He served as chairman of CSI and IET Kolkata, SLT member of IEEE COMSOC. His H index is 46, citation is 10,250. He is listed in the top 2% scientists of the world. His research interests are HAI, IoT, and quantum computing. Welcome you, sir. Now I would kindly invite our principal, sir, Professor Dr. Debashis Sarkar, sir, to kindly say a few words about our esteemed speaker. Over to you, sir.
Thank you so much, sir. First of all, our sincere thanks and gratitude to Professor Debashis, who is not only an eminent scientist in the field of computer science, But as far as it comes to Supreme Knowledge Foundation or me as a person, he is our guide, he is our well-wisher. We get each and every kind of support from him for the academic advancement. So I know he is extremely busy. He is right now attending a conference at Bangalore. But then, like, as to keep a request, he has joined this session. So, sir, thank you very much from Supreme Knowledge Foundation. As always, you extend your support and gratitude to us. And we are looking forward to your session and your support. Thank you, sir.
Thank you. Thank you, Debashis. Thank you, sir. Shamit. Thank you, Subroto Das, sir, for your kind introduction. And the topic what you have chosen is very interesting and very close to my heart. And I believe that the new generation computing is starting with this quantum computing, and this new wave of quantum computing is, generating various enthusiasm among the young students and the researchers, those who are working day and night in this new field of computing called quantum computing. As Shumit Kumar sir already mentioned, that quantum computing is coming in various aspects of our life, day-to-day life, and it is not only confined in the book of physics, quantum mechanics. It is coming as a very powerful tool of computing, and that is generating various startups. Currently, I'm in a conference where the VLSI design, quantum computing, quantum machine learning, everyone is working together, and this quantum group is working various aspects, and government of India is giving a lot of fund. We also have small group in Calcutta. So my group members are Mohanandipal from MCKP. Also, we have Dipankar, who is joining very soon. And we are working in the field of quantum computing, starting from quantum machine learning to quantum logic design, quantum circuits. So this has it has a lot of impact in our practical life, and as well as it is changing the landscape of our life. Okay. So, madam, can you share the screen? Mohammed, can you share the screen?
The screen is like we can see the screen.
Sir, I have already shared the screen.
Why it is?
Okay, I'm sharing it now. Okay, I've shared.
Okay. Just a
Is
minute.
it visible? Yes.
From my mobile, it is not visible.
It is visible.
Okay, just a minute. Let's see. Okay, now it is. Now I can see. Yes.
Okay. Okay.
Maybe
Sir.
some delay was there. Okay. So the topic is actually impact of quantum computing on various industries. So at this point of time, and I'm in a place where Bangalore, where actually at least 10 industries are there. All the government sector is also there. MAKAUT is there. They are all talking about quantum computing, and Government of India launched a mission called National Quantum Mission (NQM), and through which various companies they submitted their projects. Almost all the IITs and NITs they have submitted. Various universities also become the part of this NQM, National Quantum Mission, and India has a plan of at least 100 startups are coming up in the field of quantum computing in various industries like fintech, financial technology, healthcare, agriculture, quantum in agriculture. So that is changing the landscape. That previously, if you can remember, we are using this old what was the earlier architecture in our computer architecture book? Von Neumann architecture, right? What is von Neumann architecture? We have CPU in one place and is connected with the memories, and next part will be the input and output. Then what happened that von Neumann architecture, the problem is their memory and the chip, they are disconnected, not interconnected. And the communication cost and the transmission cost within the chip from the memory to the system, means the processor to the memory, and a lot of losses there, energy losses there, thermal losses there. and that is consuming a lot of power, right? Our target is to reduce the computing. So recently, for last 4 or 5 years, all the companies are coming up with different architecture called in-memory computing or neuromorphic architecture. Neuromorphic means in our brain, it is mimicking our brain, where the computing is happening within the memory itself. So people are thinking to utilize the in-memory computing. So computing is happening within the memory. So processing is happening within the memory, and that is reducing the cost. Please stay in the last slide only. When I will change, then change the slide.
Okay.
So first slide.
Right.
Now the question is this in-memory computing, or is also known as CIM. CIM means computing in memory, within the memory, in-memory computing. CIM, and CIM is a buzzword now in the market. So last 3-4 days I am here in Bangalore and everyone is talking about CIM. So initially, even 5 days before, I'm also not aware of the fact, and that is the reason we go to this kind of high-end workshops where the people are from the industry. They are more habituated with this kind of terminology, or in-memory computing or computing in memory, where actually computing is happening within the chip itself, and that is reducing the power, and it is reducing the power almost 90%. So can you believe it? 90% power can be reduced by using this in-memory computing. So there is a very important shift from this von Neumann architecture to this in-memory computing. That means neuromorphic computing. Why? Because it is happening. The computing is happening in the memory, and the network, the data is coming in terms of spike. You know that the data means the chip is not always on. When there is any activity, there is a spike. When there is a spike, then the chip will be active. Otherwise, it will go to sleep mode. So this is the new architecture called in-memory computing or neuromorphic architecture that came last 5 years before. That is reducing the power in a huge amount. Now recently, last 2-3 years, people are working in IBM quantum computers, Google quantum computers. We're all talking about quantum supremacy, right? So people are working in this quantum computer in very, very low temperature, that minus 273 degrees centigrade. And if you compare the power requirement compared to von Neumann or neuromorphic, it is almost 1/1000 times, maybe 1/10,000 times. But the computing power is 2 to the power n, means in a logarithmic scale, non-linear fashion, it is increasing. So if you see twofold advantage we are getting, one is the computation time is low, right? Extremely low, in very short time we can compute. So computation power is very high. So that is reducing the latency in the any kinds of computation. Any computation in Colab, it takes maybe 3-4 days. That can be done in fraction of a second, right? So these are the facilities we are getting in quantum computer, and that is the reason it is so popular among the researchers nowadays. And that is the reason maybe this workshop, this topic has been chosen, that a lot of companies are coming up, even the startups are coming up. Government of India is giving a lot of fund. Those who are listening, all the government heads are available in our workshop today in Bangalore. So they are all funding a lot. Generous funding is coming up to start with NQM, National Quantum Mission, as well as to fund for the startups for quantum related projects, right? You can submit your projects or startup. The funding is coming. Funding is not a problem. Okay, I think that is a topic of today's talk, that impact of quantum computing in various industries, especially for the startups. Startup is coming up for last couple of years in India rapidly, and a lot of people are showing interest in the spin-off company. Even some of the teachers, they can also open their own companies, right? So this is actually happening in all over India, where people are talking about quantum computing. But before we go for what is quantum computing, let's see what is actually what is the basis of quantum? Why the term is so popular? What is the power of this quantum computing, right? So next slide, please, madam. Yeah. If you see the bulk material, bulk means material without any quantization, right? Whether it's silicon or gallium arsenide. You know, when you're talking about chips or fabrication or devices, our computers made up with chips, right? Whether it is silicon or gallium arsenide, they are actually bulk material. Bulk means without any quantization. So you can see there is a density of states versus electron. Density of means number of electrons. DOS, density of states, or DOS, we call it DOS, is called number of electrons per unit volume per unit space. Now we know the very simple formula that energy equals to h cat square k square by twice m star, right? E equals to is proportional to k square. K is the energy vector, right? So we can see there is a parabolic graph. E is proportional to k square. It is a parabola. So if you see the first figure, figure 1, for bulk, can you see this is a continuous curve? This is for normal material, normal silicon. Says, suppose we are talking about silicon. Normal silicon energy is continuous, which is available in our normal laptop, normal tablet, CPU, everywhere, right? There is no quantization. It starts with a simple formula, E equals to half mv square. I think everyone know that school level, E equals to half mv square. So if you mv, if you talk about in terms of quantum mechanics, it is E equals to h cat square k square by twice m star, where m star is the effective mass, h is the Planck's constant, and k square is the wave vector, right? Energy vector. So E is proportional to k square. So it is a parabola. So that is the reason we are getting a parabolic graph, energy versus density graph, right? Now if we go to quantum well, can you see the quantum well? There is some step-like structure, right? Steps. Quantum well means what? One dimension is quantized. If you see three-dimensional, kx, ky, kz. Kx means k is a vector in three-dimensional vector. Kx in x direction, ky for y direction, kz for z direction. Suppose we have quantized in kx. Quantized means what? Can anyone say what is quantization? What is kx? Kx means if you reduce the dimension, if one dimension means at least out of three dimension, if you reduce one vector less than 10 nanometer, or maybe less than say 100 nanometer, we can tell it is a quantized, right? Any semiconductor approximately less than 100 nanometer is quantization. Generally from 1 to 100 nanometer is basically quantization, right? If you quantize one direction, it will form a well, right? So one direction is quantized. So we call it quantum well. And you can see the step-like structure. So it shows that from continuous graph, we are getting a discrete energy level, density of state, right? Now, if you quantize out of kx, ky, kz, if you quantize any one of the two, any two, then it will be quantum wire. Wire means it is simply a wire because both the direction kx and ky is not there, means is lower than 100 nanometer, right? And that's why it's formed like a wire, like a cable, right? So you can see the energy is more quantized in case of quantum wire, but in case of quantum dot, kx, ky, kz, all the directions are not there. So it is like a small box of 100 nanometer by 100 nanometer by 100 nanometer, or 50 nanometer by 50 nanometer by 50 nanometer. Small box. So what will happen? All the electrons will be quantized in a very small space. So it will be highly quantized, right? So we are getting some discrete peaks, discrete energy of states, right? This is called quantum dot. So quantum well, quantum wire, and quantum dot. These are the three basics of quantization of any material, right? And it is only possible at very low temperature, minus 273 degrees centigrade. This kind of quantization is possible. Okay, when the device dimension is called, less than 100 nanometer, right? We call it, sometimes we call it as nanotechnology, right? Nano computing or nano devices. Here. So any question? Debashis sir, is it okay? Or any question? Subroto sir, is it okay? It is
Yes, sir,
understandable.
fine. Yeah, it's fine, sir. So, just
So you
with your
can
kind permission,
understand.
Professor,
Yes, yes.
with your kind permission, dear participant, if you have any question, then please raise your hand, and if you want to interact with our esteemed speaker, then please raise your hand. Thank you.
So
Thank you.
that basically, yeah, if you quantize one direction, it forms a quantum well, right? Shantar. If you quantize two direction, it forms a quantum wire. If we quantize three direction, kx, ky, kz, it forms a quantum dot. So which one is more confined? Which one is more quantized? Obviously quantum dot, right? So quantum dot is more powerful. Quantum dot lasers are very powerful, very, very popular and powerful. Very high intensity lasers are possible. Quantum dot is very popular for laser design. Quantum laser. Okay. Nano lasers are mostly quantum dot lasers, and sometimes this. You see, from continuous parabolic graph, you can see a very discrete levels of energy that indicates it is highly quantized. Quantization level is very, very high, extremely high. If the quantization level is extremely high, it can show very high quantization properties, right? So quantum well, quantum wire, and quantum dot, these are the basic three devices, right? Dimension of the device, which is used for within the quantum computers, right? To develop this, the various architectures, right? Okay. Next slide, please. So we can see it was similar that it says 2D quantization means quantum well, 1D means quantum wire, and 3D means quantum dots. So you can see very high discrete nature it is showing, right? Okay, next. So we have plotted three, means the blue color is basically quantum without any quantization, bulk material. That means our normal computers. There is no quantization. And the step-like structures are basically quantum well. And this violet one is basically quantum wire. And the green one is quantum wire. And the, I think, black color, no? Black color is basically quantum dots, right? So it is showing all the things, four properties together, how the density of states behaves. Density means it is similar to our population density. Here the density means density of electrons, right? Energy density. Density of states. Actually, this governs the basic properties of a quantum computer, quantum chips, right? Next. Next, please. So, yes. So already you have seen the various kind of quantum confinement from bulk to dot well to wire to dot. Next. So by this way, actually, we can achieve various kind of quantum logic. Now, this kind of small dimension material we cannot fabricate in room temperature. That is the biggest limitation of this quantum computer. So I was fortunate to work practically. To develop this quantum nano devices. We worked a lot, in this kind of structure, where we are placing or developing this quantum well structure or quantum wire structure or quantum dot structure with molecular level. With one is to one molecule, we can select and we can develop the structure, right? And it is working at a very low temperature, means minus 273 degrees centigrade, that means 0 Kelvin, and also at very low pressure. Pressure means you have to make a vacuum to make it 100% vacuum, means almost 100%. 10 to the power minus 12 millibar. Can you believe it? 10 to the power minus 12 millibar. That much kind of low pressure we have to make the vacuum within the chamber, and with the help of the rotary pump and various other pumps, right? At least I can remember we have used 4 or 5 pumps, and it takes almost 12 to 15 days time to make this vacuum. To reach the vacuum, it goes step by step. First it goes to 10 to the minus 3, then 10 to the minus 6, then it will go to 10 to the minus 9, then 12. So unless and until you reach the vacuum, and so ultra low scale vacuum or 10 to the minus 12 millibar, we cannot start the fabrication. After reaching this, this low pressure, low temperature, we can actually fabricate those quantum well, wire, and dot structure within this system, within the chamber. I think you must have seen this structure in Google search, right? So I practically worked in this kind of modules, in the structures, right? We call it molecular beam epitaxy and various other growth techniques to grow these nano devices and nanomaterials, right? Which shows very good quantum properties, right? Quantum processing is coming, and Google, IBM, especially IBM and Google, they are the pioneers. First IBM started long. After that, Google also did it. And nowadays, many companies like IonQ and many Rigetti and many companies are coming up that to develop this quantum processing unit in the system, right? So what is the biggest limitation? That anyone want to buy, those who are listening, I can see 156 participants are there. Know that we cannot buy the quantum computer because in our house we cannot keep the quantum computer at so low pressure and so low temperature, right? So we can buy any computer, means analog computer or any kinds of computer, but we cannot have the quantum computer at your house, right? Or even at the institute. Very costly matter. Quantum computers are very costly because the maintenance cost is very high. To keep the temperature so low and pressure so low, we have to make the pumps on all the times. And the running cost is almost very high, at least 50,000 to 1 lakh per day, right? So it is almost impossible to run this system like this. So that is the reason the access cost is very high. We cannot use this quantum computer directly, but we can access it online. I think IBM Q is a very, very popular machine. Almost everyone use it, right? And we have Mohanandipal madam. She is expert in that domain of using this IBM Q, using QSkit. Language is QSkit. That is a Python-based language, QSkit, and which is used to program, which is used to develop the logic gates using this quantum processing units. So just like we have AND gate, OR gate, NOT gate in our analog computers, or that shift register, multiplexer. Similarly, we have various other basic processing units, CNOT gate, Hadamard gate. So that kind of logic, similar equivalent logic we can develop within the quantum computers, and we can do addition, multiplication, various kinds of mathematical operations, integration, and various algorithms we can run in the quantum computer, but through the cloud access. Only we can access the quantum computer through the cloud access. Cloud means quantum as a service. Like that cloud computing, what do you do? Platform as a service, infrastructure as a service, and software as a service, right? So we are using this quantum computing as a service model. We call it QoS, quantum as a service, right? So it is very costly matter, right? Nowadays, QSkit is giving only 10 minutes. Earlier, when Mohammed and we started this work for 2-3 years before, it was that it was almost free. Simulator and this, we can use it for at least some level. Nowadays, they are allowing only IBM is only 10 minutes for access charge, access cost. So access is only 10 minutes, especially for this, learning community. For any big loop you want to run, that it is very chargeable. So we are also using Amazon services bracket for this. So I think we have a project. So with the project, we are getting the access of this. Otherwise, it's very difficult to access this quantum computer to run your own algorithm in the system, right? Okay. Any question from this? This is a quantum processing unit.
So if you have any question, then please raise your hand. Your participants, if you have any question, then please raise your hand. Professor, please proceed.
Yeah. So is it clear now that quantum computing is not possible at room temperature, right? So we are accessing all it very cryogenic. We are is called cryogenic technology because liquid nitrogen is used, very low temperature, low pressure. We are working. Okay. Next, please. So Google, Microsoft, IBM, everyone started their journey, and we are using maybe 8 qubit, 4 qubit. In case of classical, we are talking about bit, but in case of quantum, we are talking about qubit. We have a third state, right, where entanglement is quantum entanglement. We are making a sphere called qubit sphere, right? And the company, that country like China, they achieved this quantum supremacy. They've already developed this quantum computer which can communicate up to moon in a fraction of a second. Okay? That is also possible. Even IBM has also already shown that they've developed this 1000 qubit, but that is not free. Mind it, that is not free of charge, free of cost. Only they are using 4 qubit or 2 qubit as or that is also for only for 10 minutes. Okay. Next. Okay, so I already mentioned that what is the limitation of classical computing, that it is slow, basically slow processing, but quantum computing is very high with the help of the superposition and parallelism. Okay, and solutions are very high speed up, and it features that shows the entanglement, and also that it provides high state quantum states and very high speed processing units. So that is the reason we are shifting towards computing, especially for large scale data in the cloud data. The quantum computers are so popular. Next. Next, please. Next slide, please. Hello. Yeah. If you see the quantum hardwares, that no before that. No, already you've crossed. So you see the quantum cloud providers, various quantum cloud providers are there. No, just go before. We already skipped lots. Back, madam. Back side. Back.
It is showing cloud providers.
5 or 6. 7. Okay. It is 13, I can see.
13. Oh. 11. 12.
Go back, please.
Back.
7, slide number 7. It is now slide number 12, I can see.
Slide number 7.
Yes.
7.
Go back. Back 7.
This one is 7.
Yeah. Yeah. Let's keep it here. Next.
Okay.
Next.
Next.
Slowly move. No problem.
Slide number 8.
Next.
Next. This is slide
Now,
number 9.
fine. Already I mentioned the limitation. Next. So we know that people are slowly moving towards cloud-based computing. So quantum computing is getting QoS, means quantum as a service, cloud-based service, because of the limitation of slow computing in case of classical computers. Next. Slide number 10.
10.
You know that we use this computing, you know, I was in Melbourne, so we have seen this quantum computer very closely. IBM Q at Melbourne University is there in Australia. So this is the directly, you can see the real quantum computing computers, you know, the view from inside. And you can see that all the connects are gold interconnects because gold has very good connectivity, means conductors. The next 11 slide, please.
11.
Okay. Now see, there are 4 types of quantum computers. Okay. First is supercomputing qubit. Supercomputing. Okay. Supercomputing, you know that it works at a very low temperature. I was talking about, since last half an hour, I was talking about only for low temperature processing, low temperature, extremely low temperature processing. So supercomputers are basically, it conducts without any charge current losses, right? So supercomputer is very popular sometimes, and IBM uses this IBM Q, the supercomputers at low temperature. It shows very low error. Supercomputers are conductors are very, very popular in case of quantum hardware, right? And there are other technologies like topological qubits, right? Also photonic qubit, means optical qubit. And the last one is ion trapped ion qubit. Means, you know, ion will be trapped within the qubit as in form of qubit, right? In case of binary system, normal computer, we call it bit, but in case of quantum computer, we are calling it as qubit, quantum bit. So it is forming a block sphere kind of atmosphere where 0, 1, and half, you know, the third state also exists anywhere in the sphere, right? So these are the 4 basic hardware types, and various companies are using various kinds of hardwares. Like IonQ is one company, IonQ, they uses a strapped ion structure, right? Slide 12, next. Now these are the companies, IBM QSkit. They are the SDKs, means software development kit, and Google Quick is another language they are using, you know that. But Google is not giving access. Only IBM QSkit is giving access. That is only from last few months. Only 10 minutes they are giving access, right? So these are the other kinds of SDKs you can available for usage, right? Next. We use Amazon Bracket for this. So these are the, you know, we have the project from Amazon and Métis. You know, Métis here is currently in this hotel where I'm staying now, and you know that the Métis is giving a lot of funding for this Amazon Bracket, and this is a joint project of anyone can, I think anyone can apply, or you can work with us jointly for this Amazon Bracket project. And I think Dipankar is here, Moha madam is here. We are working they are working extensively in this Amazon Bracket for various quantum machine learning applications. Okay. Also, Microsoft Azure is giving services, and Google Quantum AI. But these are all paid mostly. Only Amazon Bracket and IBM Q we can get some funding from funding agencies. Okay, next. Now I call it rainbow of quantum computing. Rainbow means, you know, that in terms of industry, quantum industry, I think your Debashis sir has correctly pointed out what is the impact of this quantum computing in current industry. So next slide. So there are 7 important areas I have identified. I'm calling it as rainbow of quantum computing. So first, actually, we are working extensively in our group. We have one project called Quantum Healthcare Project, and in various parts of India and part of the world, they actually work day and night for quantum healthcare, for processing of image processing applications, for the large scale data analytics, also for large image analysis in the cloud, and also provide the forecasting of any kinds of pandemic or any kind of disease. This quantum healthcare is providing a huge amount of impact in our day-to-day life. Similarly, quantum computing is coming in a big way in agriculture industry to provide the satellite map images and also giving recommendation of growth of food in various areas based on the soil moisture and various other things. And high-end computing is possible for agriculture. Pharmaceutical industries during COVID time also, that the vaccines are prepared, the computation is performed, gene analytics is performed using this quantum computing, right? So with ultra high speed quantum computers, processing speed is very high, and pharmaceutical industry for new drug discovery. I think in the introduction, the anchors have already, Subroto sir, Science sir, everyone mentioned that quantum pharmacy is a very popular, especially for targeted drug delivery, new drug discovery. Pharmaceutical companies are working together with new molecules and patterns of protein pattern, how this protein is attracting each other and how the medicinal effect. Everything can be studied using this quantum computer, which generally takes maybe 1 month and years of time, which can be done in fraction of a second because of high power computing facilities in quantum computers, right? Quantum computing is used in our DRDO. In India, DRDO is using this quantum computer. Okay. They are also doing QKD, quantum key distribution. The key distribution is very important for quantum cryptography. And there are various groups in Bangalore. I'm just very close to me is ISC Bangalore and Raman Research Institute, where you might have seen Urvashi Sinha. They are working in this group in Raman Research Institute for satellite-based key distribution. She is very famous. Urvashi Sinha is very famous for this QKD. He worked almost 5 to 6 years in Oxford, I think, and after that, she is developing the quantum key distribution in our DRDO setup. India has now defense industry. They are also using this quantum key distribution technology in optical level, optical quantum computers. So, yeah, these are the facilities that are coming up in India, and as well as side by side, lot of startups are coming up for quantum key distribution, QKD, right? QKD is so popular. Quantum key distribution is so popular nowadays, and a lot of industries coming up. Okay, I know that one of my friend Andrew Lord, he's from a company from UK. They're also one company is dedicated for this, this distribution of quantum keys and everything. So defense sector, quantum communication is very, very popular. Quantum computing. Next, quantum computing is also coming in a big way for communication industry. I'm also working as an editor of a journal called IT Quantum Communication. Okay, if you're interested, anyone is interested, I can see 166 participants. You can search IET Quantum Communication. We are having quantum, how this quantum technology is used to develop this transmitter, receiver, repeaters. These are the basic components. Quantum modulation, demodulation. So optical modulation and quantum, 5G quantum technologies, even 6G technology, which is we are talking about, that will be totally based on the quantum cryptography and quantum, quantum based high speed communication, right? So 5G, 6G is coming up with the help of this blessings of quantum computing and quantum communication. So communication industry is also booming up, right? And similarly, you can see quantum computing about fintech. Fintech means financial technology. Banking sector. There is one of my friend. He's working extensively on fintech. So the banking, that we have to have huge amount of data. You just imagine 150 crore Indians are there. So how much amount of data is generated for their bank account transactions? And that transaction, that setting up takes a lot of time. But using this help of this quantum computer, nowadays we can do in fraction of second, right? So this is the beauty of our quantum computing, which is helping for our society, for financial technology to grow together. Also, there is something is called post-quantum cryptography, where you see if you use a quantum computer, RSA and DSA, AES, those algorithms we can break in a second, right? Why? Because quantum computing has that power of that much amount of permutation combination to break the key of quantum computers like DES, AES. So everything will be invalid. So we have to rewrite the theory of quantum cryptography. Also, we call it post-quantum cryptography. Like this, a lot of theories are coming up. I think BBQ algorithm, right, madam? BBQ.
Sure.
BBQ.
Professor Dev, sorry to disturb you. Actually, you have two questions from the audience written in the chat box.
Okay.
How does processing take place in quantum computing? Dr. Mohadev.
That in case of classical computer, we are using bit. But in case of quantum computer, we have extra state. It's like a sphere, like a football, right? 0 and 1, and something in sphere. That is called quantum entanglement. So state can be anywhere on the football, right? So that is called quantum entanglement. So that is giving the 2 to the power n power computing power, right? In case of classical computer, we are talking about n type. Here it is 2 to the power n. You can understand it is quantum computing is doing high speed computing, means 2 to the power n, logarithmic way it is increasing, right? So for example, 3 bit to 4 bit. In case of classical computer, how many bit increase? Shayan sir? 3 bit to 4 bit. In case of classical computer, how many bit increase?
Bit is increased by
Only
1
one, right? Only one, right?
Only 1 bit.
But in case of only one, yes. But in case of quantum computer, it is 2 to the power 3 to 2 to the power 4.
Right.
So you understand how much it will increase the power, right? You understand? So that is the beauty, that is the power of quantum computer because of qubit, right?
And the second question is, how do we achieve parallel computing in quantum computing?
That parallel computing is possible because of this entanglement. Quantum entanglement allows you to process the data parallelly, and you have multiple n number of qubits. Then every qubit has a processing capability. So parallel processing is possible very much in case of quantum computers. So that is the reason it is very high speed computing, right?
Okay. Sorry, please proceed.
Okay. So see, now last term you can see this is called quantum sensing, right? And you'll be happy to know we are doing quantum sensing in our Salt Lake Sector 5. Okay. Quantum sensing is happening in India practically, right? So those who are interested, they can contact us. We can show you the labs and how this quantum sensing is happening. Quantum sensing is very, very popular and coming in a big way. It will be, that IoT has a sensor, right? IoT means it is sensing and sending the data through internet. Quantum sensing is also a very powerful tool to sense the data very efficiently, even in a noisy environment, and also transmit the data efficiently through the. So quantum sensing is coming in a big way. If I'm not wrong, I've heard that maybe 7,000 or 8,000 crore rupees has been given for quantum computing. At least a majority of the share is coming in terms of quantum sensing, right? India is going to develop quantum sensors, right? I've heard, I was talking to Arpan Pal, one of the scientists in TCS. And they are also talking about that they are also developing these quantum sensors. IIT Bombay, they are developing quantum sensors, and TCG Trace, they are developing quantum sensors. So those who are interested in quantum industry and quantum research, this is the best time, right? This is the best time to contribute, and this is the best time if you can have a spin-off small company, right? And you can have a lot of fund out of it. And government is supporting with these startups, quantum startups. And if you see the CDAC and chip, they have started chip-in project and various other projects to support this kind of activities, right? So those who are talking about industry, this industry has a very high scale and long-term advantage, right? Because quantum computers are giving the fruit nowadays. Although we cannot see the quantum computers by our own eye, right? Because it is somewhere, right? Madam, we are accessing this quantum computer from outside India, right? Moha, madam, are you there? No?
Yes, yes, yes.
So which countries we have used the quantum computers?
We use not from North America, from Africa, from Japan, also from our country.
Yeah, Kolkata also IBM started recently quantum Kolkata, right?
We have used.
Yes.
These are the
So quantum
computers we have
computing.
used.
Yes, yes.
From
So
Africa,
Kolkata
from
also
South America,
started.
from
Yeah.
North America.
Yes. But all in terms of
California.
cloud format, we cannot see. We just have the access. We have just have the access of the quantum computer. That's it. Okay. Next slide, please. Now see, quantum computers are very much powerful for very accurate disease detection, disease identification. And you'll be, you know that during COVID time, this quantum computer usage is very high, just for your information, for identification of disease. And that time there was a need of the hour. And that is the reason biomedical data analysis, especially for gene analysis, health optimization, in the hospitals and the health sector, government sector, they are using this quantum computer for healthcare, right? And there are worldwide, there are largest amount of startups are on quantum healthcare and quantum pharmacy. These are the two areas where people are working together extensively. Next. Next, please. Yeah. So you see the gene analysis, you know that gene analysis means, you know that human gene, it takes how much time to analysis? 3 billion gene. It takes almost 1 month to access, right? To analyze the gene and to get a footprint. Footprint means to get a conclusion what kind of disease you have. 1 month time. Can you believe it? But if you want to do the same operation using this quantum computer, we can do this operation in fraction of second. So if you go to doctor, go to your hospital, you can get your gene map, gene-based, data analysis in fraction of second. That is the beauty of quantum computer. Okay, and you just wait. Gene mapping was very costly earlier. It takes earlier about as far as my knowledge goes, 5 years before, it is 1 crore rupees, right? Suppose I am Debashis, my gene analysis of full body gene analysis may take from the blood sample. It may take 1 month time and almost 1 crore rupees, right? Now with the help of this GPU, TPU, now it is possible maybe in 10 days, but the cost is around still 1 lakh rupees. But if you start using this quantum computer, maybe you can do this operation. Means you can get the data of your blueprint of your gene. You can say, you can predict what will be your age, what will be your, what kind of disease you may have in future, right? That can be also detected. Similar to X-ray and also other USG, this quantum computers can also give you gene mapping, even at very low and affordable cost, right? Because it takes very, very high-speed computing facilities. So people are thinking and also started. Some literature data is coming out in this year 24-25. It is reported in Nature that gene analysis can be done in few seconds, right? So by that way, you can predict our health data. We can do our predictive maintenance of our body health, right, by using this process. So healthcare industry is a lot of advantage we are getting using this. Next. Any question up to this in healthcare, quantum in healthcare? Shahan sir, is it clear?
Participants, if you have, please raise
Subrata
your
sir, is it clear to you? Subrata sir?
Yes, sir. Yes, sir. It is clear.
So you understand that we go to X-ray, right? Why you do X-ray? Why you do ESG? Subrata sir.
For detecting any deformities in the body.
Exactly. But if there is a deformity in the gene, is it not the good thing? You can predict some problem in the gene. You can accordingly take the medicine, right? Predictive maintenance of the body. Here.
Yes, sir.
It was very costly earlier. Now it is coming in a very affordable cost using this quantum computer. Okay.
Okay.
Next. Okay, agriculture. Sorry, agriculture. Previous slide. Agriculture. That crop production. India, country like India has 75%. This crop optimization, climate prediction, soil analysis, supply chain logic management. Everything is done by with the help of the quantum computers and very efficiently and very fast. Crop optimization, especially from the satellite images. The recommendation system where which farmer will grow which kind of crop, that is done by using the quantum computers. Okay, that kind of facilities we are having in case of agricultural industry. Next, pharmaceuticals. Already in the beginning the anchors have mentioned that pharmacy industry is the most rewarded industry because that which gene or which drug will be best used for disease cure, right? Drug discovery. From that point of view, drug discovery point of view, pharmaceutical industry is booming like anything, right? And that it will be extremely helpful for us if we can use this drug discovery. And this is the most, if you ask me, out of the 7 rainbows what we have detected, or rather we are discussing today, this pharmaceutical is the most critical industry and one of the most popular industry because medicine industry is very popular, right? And medicine is the need of the hour because of a lot of pandemics are coming up. To give to detect the and to get the result very fast. The pandemic like COVID when it came or any other pandemic, it can detect very fast what will be the problem. What is the problem? What is the problem? What is the drug required for what kind of disease? If molecular level, we can find out molecular level what kind of bonding is there and what is the best drug can be used for detection and cure, right? So pharmaceutical industry, the quantum computer is extensively used and scientists, there are various quantum pharmaceutical research coming up, that big way. It's very popular in various countries, right? Okay.
Sir, sorry again, sorry to disturb you. One question from the can you please make few Indian hospitals where quantum computing is used for the healthcare?
There is no Indian hospitals are there. They are using this quantum computer for your information. But there are various quantum computing is used for pharmaceutical industries or most of the major pharmaceutical industry, they are using quantum computing.
Okay. The question is from
Hospitals are
MAKAUT.
not using. But pharmaceutical, they're already using. Okay.
Okay, sir.
Best of my knowledge, right? Already I met with the scientists in various webinars in the discussion in the quantum group. So we have discussed that, and we have shown that how this quantum computing, how the protein to protein drug is interacting. They're showing live, okay, how they have discovered the drug, right? So I worked with them, so I know what they have done, but I have no idea that any hospital is using this quantum computer. But maybe in near future, uh, they can plan, but I have no idea. I have no information actually. Okay, so no company is using this quantum computer for this hospitals. But
Okay, sir.
but
The
just but
participant,
listen,
thanks.
for diagnosis, there various companies are using. It's called Human Genome Project. Something is called Human Genome Project. What is that? To find out the gene, find out disease in the gene. That is not done by the hospitals. That is by the experts, the scientists. Scientist level, healthcare is happening, right? Not in hospital level. That means diagnosis part is happening, right?
Okay, sir. Please proceed.
Okay. Next, please. Next slide, please. I already told that satellite communication, that they are using this surveillance. India has a big border. If you want to control, say, hundreds or thousands of drones for surveillance and for quantum key distribution, if the key is disclosed, is the problem. So Debashis and his group in Raman Research Institute in Bangalore, they are using extensively for defense. That India is using quantum computers in defense. This is a good thing. You're asking for hospitals. No, the defense sector is using quantum key, right? Okay, next. Next, please. Satellite to satellite, they are, that they are doing this quantum. So I told you that I have a journal called IET Quantum Communication. So if you visit that journal, you will get how this this communication is happening, what kind of modulation is happening, okay, what kind of transmission, what is the quantum channel, what kind of key distribution is happening, what kind of improved data compression is happening in case of quantum optimized network, right? So I'm also one of the editor of this journal. So I think our group is also publishing in those journals and all these things. This is very popular journal in the field of, maybe the only one journal in the world who is publishing in this communication, quantum communication, right? IET Quantum Communication. Please look at it. Those who are interested in quantum communication, please look at it. Okay. Thank you. Next. Yeah, fintech, financial technology for fraud detection, right? Secure transaction. That quantum like blockchain and all this technology coming up. To make it possible, we need risk analysis, fraud management. So to perform these operations, we need very high-speed quantum computers. Even that Indian Railway, they are also these railways. They're also thinking of quantum computing facilities implementation for high-speed applications, right? Quantum chips are developed. Various company. Last 3 days, I'm in a chip development, chip design conference called VLSID, where all the companies all over the world came here. Last 5 days, we are listening to their talks, and all the leading industries are there. They're developing this quantum chip for various industries. All the 7 industries I have mentioned, starting from this agriculture, healthcare, financial technology. You'll be surprised to know some of the companies they are using the chip. Their chip is disclosing your data, right? If your financial data is leaked from your mobile phone or your laptop or your computers, you are at stake. So they are doing hardware security, right? So my friend was there, Debdeep Mukhopadhyay, also Gorg from Marvel Technology, from Intel. They're all discussed for last 5 days about the quantum hardware. right? Quantum hardware, quantum hardware security, right? Hardware security is very, very interesting area. Using laser, using thermal analysis, using spectrum analysis, that we can find it out how this, how much vulnerable your chip is. If your chip is vulnerable, that you should not use it. We should not use those computers for your company or for your banks, right? Or banking transaction, right? Because you may have fraud kind of thing, right? Either in terms of hardware or in terms of software. One of my friends from Germany, Bremen University, he's working laser. He's pointing a laser and telling whether chip is fake or not. No. Now this kind of intruder chips are coming up, and quantum computing is playing a major role. That to find out the security, providing the securities in the financial technology like banking, right? Thank you. Next. Next, please. So I already mentioned the quantum computing as a sensor for medical, environmental sensing, monitoring. Quantum sensors are so popular, and also quantum sensing and IoT. And various industries in India is working in the sensing and IoT. Okay. Last 5 days I was listening a talk. Everyone is talking about intelligent sensing. I asked, what is intelligent? They are all talking about it is quantum sensing, right? Intelligence means you are providing these machine learning techniques like deep learning, explainable AI, everything within these sensors. So within the edge of the network, they're providing these facilities like AI and quantum. AI and quantum is the future. And now we are not talking about machine learning. We are all talking about quantum machine learning. Okay. So Moha madam is here. I think Deepankar also may have joined. So they are expert in the domain of quantum machine learning. Yeah. So they are expert in the domain of machine learning, quantum machine learning. So maybe you have heard about machine learning, but maybe we'll show some demo now with quantum machine learning. We call it QML. Okay. And that is the future. That is the future. So we are doing some high-speed processing in quantum, and quantum sensing is so popular. So this is the more or less I've covered next 1 hour, that how this quantum computing is coming into the picture and is providing the solutions for a sensing level and IoT level to provide these operations, right? Next, please. Next. So smart cities, the smart cities, smart security, everywhere we are coming in the terms of healthcare, right? So, now people are thinking about quantum city. Maybe you've heard about smart city. Now people are thinking about quantum city. Not thinking, they're planning to implement, where everything will be governed by high speed and high efficient quantum computers, right? So I think I've covered theoretically. Maybe you will like to see what actually we are doing, right? Maybe Deepankar or Madam, anyone can share our quantum facilities, what you have used from bracket, right? Theoretical portion we have covered. Maybe if you're interested, Shayan sir, are you there? Subroto sir?
Yes, sir.
So are you interested to see what actually we do in quantum computer?
Yes, sir. Yes, proceed.
Maybe we can show some hands-on basics, how we can do it. Deepankar, have you joined? Yes. Yeah. Deepankar, have you joined? Moha madam, Deepankar has joined?
So I think he has joined. I'm confirming. Oh,
You can
Deepankar
just
is
show what is
muted.
the basic. Yeah. Subroto sir, can you allow Deepankar to
Sure.
share the screen and show our real quantum computer, how we log in to the quantum computer as a cloud service? Next 15 minutes we can show, 10-15 minutes.
Well, just for the clarification, sir, is Deepankar Hajira or Deepankar Shaha?
Deepankar Hajra. She will be sharing the screen also.
Okay.
Yeah, he'll be sharing the screen and show the real quantum computer login of Amazon bracket. project of Amazon bracket. So
Dipankar sir, please share your screen.
Yes. I'm sharing.
Okay, thank you, sir.
yeah. So Deepankar will share the screen with the. You log into the quantum computer and you can show the history what we have done for quantum machine learning and quantum computers with basic logic gates, just for 10-15 minutes. We have to wrap up within 15 minutes, so please show it. So yes, over to you. Over to Deepankar.
Yes.
Start from the scratch. Start so that everyone can understand where you are going.
Okay,
But
sir.
don't show the password, otherwise you show this. Yeah.
Okay, sir. So actually we have done our project actually in quantum simulator and also in quantum hardware. In quantum simulator we have executed in the program in Google Colab. So these are the some code I will discuss, and then also quantum hardware through Amazon bracket. So I am opening this first, the hardware. So we have to sign in. For signing through, so this is the AWS. We are signing using the root user email.
Actually, we have this facility because we have one project on quantum machine learning from Ministry of Electronics and Information Technology. That is why we're getting this facility to access quantum hardware.
Okay, so this is the root user, this email, then password, and then one code is generated. I'm putting the code. Okay, so this is the Amazon Management Console, and here is one icon is there, this Amazon bracket. So we have to click this Amazon bracket.
So many services are provided by AWS, but Amazon bracket is for quantum computing.
So now the server is there from different servers. Servers are located in different places, like in the top corner, this United States, North Virginia, then this Northeast zone, then North California. Then these are some are enabled. That means these servers are quantum computers are available, like North Virginia, North California, then some servers of Europe, then London. This server is available, that is Stockholm. So these are the some servers are available, some are not available. So now here
at some point of time, all the servers are not available.
That is not the thing, but how much qubit they have? Just mention that.
Yes. Then these are the different devices. These are the available. Okay, so these are
Even
the
the company's name, the Amazon AWS, IonQ, the company name,
yes.
Rigetti.
So these are the okay. These are the hardware provider. IQM.
First three names SB1.
1 minute. Sorry.
SB1, TN1, and DM1. These are the simulators provided by AWS. Others are hardware, quantum hardware. IonQ is provided. Area 1 is provided by IonQ. Area 2, 40 also. Garnet provided by IQM. Aquila by Kivera and Anka by Rigeti. Rigeti, Kivera, etc. are the service providers, quantum service providers. Please continue.
Some of these are so how many qubit it's also written like SB1 34 qubit, TN1 50 qubit. So this area 1, area 2. So these are now offline that no program cannot be run here. These are the 25 qubit and some are now this Aquila, this is a 256 qubit. If we click this area 1, so we can get details of it. Okay. Now these are the different devices. Now then there is option, this is called notebook. So notebook, these are option, these are showing stopped. That means this notebook, first we have we have to write program in this notebook. Now these notebooks are stopped. So suppose we want to run any program, so or write any program, so we have to click it here and we have to make it action start. So this
I am
will be
interrupting once here because if we are not stopping the service, in that case, a large cost will be incurred. So each time will be the service will be stopped. After using the service, each time it will be stopped. Otherwise, a large amount of cost will be incurred.
It will be stopped, not we have to stop it. Otherwise,
Yeah, we have to stop it explicitly. Okay.
it will take time to be started. So I am going at that time. I am going to the simulator part that we have run in the collab. So it will take some time.
Please go to the collab part. Better, please run in the collab part. Okay. Because in hardware, it will take time to run.
Yes. So here, so this is just simple program. This is a draw quantum circuit. So only some just simple quantum circuit is shown. So for running this QML program, this quantum machine learning program, we have used this PennyLane, this open source software framework. So we have used this PennyLane software. Then from PennyLane, we have used the quantum circuit. Means with the help of this PennyLane library, we have designed our quantum circuit. So in PennyLane, there are different simulators are available. So one of the simulator is that is actually default qubit simulator. So in our experiment, we have used default qubit simulators. So this the just here this one just one qubit quantum circuit, just like shown here. This is nothing has been done. So this is the input and just output. This Z is showing this is the output. Then okay, we are going actually to our, so one of the actually in quantum machine learning we are using parameterized quantum circuits. That means parameterized quantum circuit means there will be in parameterized quantum circuit there will be different gates will be there. So these gates actually what the gates will do, the gates will means update the update. So this you can understand that 0 1 2 3 4 up to 5 6, that is this 0 to 6, these are actually 7 qubit, and on this 7 qubit means quantum bit. Quantum bit can take, as we know that it can take 0 value, 1 value, or mix of 0 and 1. That is called actually superposition of 0 and 1 value. So on these qubits, there are different quantum gates are there. The quantum gates can act on the qubits. Okay. So some of the quantum gates are like this one, ROI gate, this actually rotates the qubit along the y-axis. So some of the gate are there.
Dipankar, please put light on parametric gate and non-parametric gate.
Yes, ma'am. So this RY gate, and inside this first bracket, these are the actually RY gates actually take some parameter. This parameter means actually this is the angle theta. So RY gate rotates the qubit along y-axis with certain angle. So RY gate actually rotational Y gates rotates an angle theta around y-axis. So these 7 qubits are rotated by RY gate. So here we have just drawn it with 0 degree of rotation. So this can be any degree of this rotation can be of different degree. So this RY gate is actually called parameterized gate. Parameterized gate means this gate can take parameters. So RY is one type of parameterized gate. So, and this X gate, because this is actually CX gate, this CX gate actually entanglement gate. Entanglement gate, what the entanglement gate is doing, that means these are actually connecting one qubit with another qubit. So CX or C0 gate basically like the first entanglement gate. So this called control qubit. Control qubit, if the control qubit is in one state, then it flip the state of second qubit. That means the qubit 1. Similarly, next entanglement, it will connect it from qubit 1 to qubit 2, next entanglement gate qubit 2 to qubit 3, like that. So in this parameterized quantum circuit, there are this RY gate is there which are taking parameters, this just nothing but the angle, and this CX gate, this CX gate are not parameterized. These are actually non-parametric gate. So actually two types of quantum gates are there. This is parametric gate, another is non-parametric gates. So what is the use of, what is the difference of parametric gate and non-parametric gate at the time of QML operation is, that means when the this training will be done, these parameters will be changed, these angles will be changed to classify. So we'll, for machine learning operation, suppose we are doing any classification, suppose we are doing some retinal image classification, it's affected with disease or not affected with disease. So machine learning at that time, so some optimizer, some classical optimizer will optimize it with some number of epoch. So at that time, at the time of training, this RY gate, this angle of the RY gate will change to get the desired result. Or if we want to get the highest accuracy, so these angles will be changed. These angles will be used as the parameters for learning process, or we can say the quantum machine learning process. So there are other different gates are also there. We are used.
Yeah, Dipankar, can you show the qubit first? Can you show a qubit sphere, block sphere? A block sphere, please show it.
Sir, I would like to interrupt once. There is a question in the chat box. Please show us how to submit a task to quantum computer and its execution results.
Okay.
This question is asked by Dr. Sasmita.
Yeah. Yeah, first show the qubit, then show our old records results, how we have uploaded and how we have done it. Okay. Just don't show the steps. That's it. Do not go in detail. Okay. Okay. Show the qubit first, then show the how you upload the job.
Okay.
Just basic, not uploading real, but show the previous records, how you have uploaded. Steps only. Okay.
Okay, sir. Sir, I'll show the qubit later. I'm showing the quantum job here. I'm checking this qubit block sphere actually.
Okay. So this is still now pending. Started.
So you can just show the rotation, or you just show the what is block sphere. That's it, so that I can understand that to the power n states how we are getting
Okay, sir.
one qubit.
Block sphere,
Block
please
sphere.
show.
Yeah, you can show your image also, no problem.
Image.
Yeah. Then show what run software, what they're asking.
Okay, sir. Then I'm showing from Google, sir. Block sphere.
Block sphere and how the parametric gates are
Achha,
rotating
so
the
actually
qubits.
block sphere. So this is the block sphere actually. So this upward, this one is actually called ket 0 actually, or qubit 0. And if this downward direction, if the arrow is there, this is called actually that is actually ket 1 or qubit 1. So here it's written ket 0. Okay, and here it is written ket 1, or this is qubit 1. So there are three axes: x axis, y axis, and z axis. So qubit can be in 0 state, ket 0 state, or ket 1 state, or mixture of any state, that is superposition, or we can say that superposition of any state. Qubit can be in this position, or in this position, or in this position, in between any position. That means that qubit can be 0 state, this upward direction, 1 state, or mixture of any state. So this is the actually the block sphere.
So for due to superposition property of the qubit,
Yes.
we are getting this type of activities. Unexplained entanglement also, these are two primary properties of quantum state.
That is the reason we are getting to the power n.
Yes.
Bit can be only 0 or 1. So here it can be 0, that is ket 0, or ket 1, or any superposition of 0 and 1.
That means
That is
anywhere on the
superposition.
sphere, any place, any points on the sphere, or the football, right? Sphere.
Yes.
Any point on this football. That is the reason we are getting.
All the points on the football presents each and every state. I think hardware is not ready till now. You can please run the simulator first. Because the hardware is not ready till now.
Yes.
It is taking time because the job queue is associated with each of the hardwares. That is why it is not ready. So far I can see. So So Dipankar, please go to the collab part.
Okay, okay.
No, I think they are asking where his job is uploaded. Show that section. That's it. We should not go many things.
This is the section. This is the section. So here we have written the code. Classify
That's it.
classify ROP dot
But how to
underscore.
upload? You just say that one. How to upload? Yeah.
Yes, yes.
Upload section.
So this is the actual program here. This device ARN, it is given. This is program is actually run in area 1. Now area 1 is now in the stopped condition. Okay, so this program was run in area 1. So here we have to fix this device ARN as area 1. This part. Here actually we are doing the hybrid job. Hybrid job means, so some part is classical and some part is quantum. So actually the simulation
You
part.
can see, you can show area 1 is not ready. You can check that also.
Yes, yes.
Area
so
1.
That I have shown in the before. Okay.
Because from here you are trying to access area 1.
Yes.
And I think area 1 is not ready. Check it.
So here this is a hybrid job, and this device equal to, you have to fix device ARN. That means if it is area 1, we have to put it device equal to, if it's area 2, then it will run in area 2, like that. So here the inside this hybrid job we have to write our program. So here for 7 qubit circuit, wires equal to 7. Here shorts is written 1. So actually we have to run multiple number of sorts, like 100 sort or 1000 sorts, like that. So this is the program. Now when we'll run this
and
program,
each of the sorts are taking cost. Per
Right.
short cost and per task cost. Two different types of cost are associated with each job. The execution of a program in the hardware.
How to upload? Go to the upload section.
job.
That's it. Don't have to show everything. I think not possible to show, because next time our is going to
it is not possible.
So yeah,
Further said,
just
it's
show
not
which job
possible
you are
to
running and
upload a
where.
job in
That's
the
it.
hardware.
Here job equal to this program name. See here hybrid job. Here we define that QP ROP classify. So this is our hybrid job. We have specified. That means this function is our doing our hybrid job. So now we have to call it. When we are calling it, that job equal to QPU ROP classify. Number of steps to, actually this will be a number of iteration. So we have to specify how many iterations are there and what will be the step size. And when we are writing this line, this job will be, here you see this AWS quantum job. So this quantum job will be created. So this line is actually calling the program and creating the quantum job. After running this line, this quantum job is created. Where created? Now it is creating as US East 1, that US East 1 server. That means if we use any other server like then area 1, there the job will be created. Now this cannot be run because now at that moment, because this area 1 is not this. If we check this device at this moment, area 1 is offline. So it can run at this moment on Garnet or Aquila, but area 1, what we have run before, that cannot be not be run now. And the program, if we give this one, that is this one in this line, so actually the job will be in the pending queued state. That means I have given this job and it will run, or running will start now. It's not like it will be in pending state. That means in area 1, suppose there will be 10 requests. So after 9 job completed, it will start running. So it may take 3 or 4 days, but it will take less time to execute, but it may be queued for some time. maybe for 2-3 days it may be queued. So this is the line to execute the job. And it is basically a hybrid job because this actually optimization is done by the classical optimization. So in classical optimization, we are using actually classical optimizer like Adam or gradient descent, this type of optimizer. Okay, I am going to the simulator part. The simulator part is actually this one of the program that is for running detecting retinal image, detecting retinal image, that is some retinal image, it is affected with some disease or not. Okay. So we have used this Google Colab and the data is available in the some CSV file. So this is the CSV files. This CSV file is created from actual image, the annotated image, the affected part is there, and some unaffected part is there. There are two classes of this retinal image. One is affected, another is unaffected. So this affected and unaffected part is converted to the CSV files. That means for affected patch, let the class is 1, unaffected patch, unaffected image, the class is -1. So here we have taken some features. If you can see that 340 features are there, and difference between +1 and -1 class. +1 is affected retina with disease, and -1 with retina without disease. This actually we have balanced those. That means 170 there's affected image and 170 is not affected with disease. Then there is another major part that is called actually encoding part. Encoding part is required. Encoding part, what the encoding part is doing, encoding part actually converting the features to the quantum bits. So there are different encoding parts are there, encoding methods are there. So angle encoding, basis encoding, amplitude encoding. So we have used amplitude encoding for the training data set. What the amplitude encoding is doing, amplitude encoding convert the CSV file, convert taking the records from the CSV files, and so that is actually classical features to convert it into the qubit or quantum bit. So we have used amplitude encoding. One of the advantage of the amplitude encoding is it can convert 2 to the power n features to n number of qubit. That means data compression is better than angle encoding or basis encoding. So it can convert 2 to the power n features to n qubits. So then next part is this one. So this code, what it is actually doing. So we have the total data is there. So first 80% we are taking as training, next 10% for validation, and next 10% for testing.
Okay, I think thank you, Dipankar. You have already given some idea. I can see 171 participants. Thank you everyone for joining. I think you got some idea that how we can do it. Maybe in future we can discuss in detail. Anyone want to work, we can get our access, no problem. We can work together. So thank you very much. I think you got we get some idea, and hopefully we can do in future. Thank you, Dipankar.
Thank you, sir. Thank you, sir. Thank you all. Thank you, madam.
Thank you, Dipankar. Thank you, Dipankar sir and madam, for this wonderful presentation.
Over to Shubhra sir. Thank you. We can close it. Dipankar, you can close it.
Okay. Okay. Thank you, sir. Sir.
Thank you, sir.
As we come to the close of this insightful and enlightening session, I would like to extend our deepest gratitude to Professor Debashis sir for delivering such an engaging and informative talk on the quantum computing impact on various industries. As sir started with the basics of quantum computing, then sir went on with why quantum computing is important, its limitations, the potentials of quantum computing, quantum SDK. Then sir went on with the major quantum cloud providers in this area. Then sir discussed in details about different quantum computing hardware and what are major quantum cloud providers and the rainbow of quantum computing. That means the use of quantum computing in healthcare, agriculture, pharmaceutical industry, defense, communication, fintech, etc. And also and with a good demonstration how actually the quantum computing works. Okay, so with this valuable
Thank you.
talk, I hope the participants have gained a valuable insight into this area and they will explore further. So with this, I would like to finally thanks a lot to our speakers and also the presenters for this wonderful talk. So now with the kind permission of our principal sir and coordinators, we would like to end this session and start on the next session. Over to the
Thank you.
sir.
One request to like Debashis there, sir. Sir, as you are seeing all the giant quantum computing maker and the scientists, once you come back to Kolkata, very soon we will be planning one physical session with our students and faculty where you will share your experience.
Yeah. Thank you. Thank you. Thank you. Thank you, everyone.
Thank you, sir.
Thank you, sir.
I think you got some idea how it works, right?
Yes, sir.
You got some idea.
Yes, sir. Yes.
Okay. Thank you.
Thank you, sir. Now I would hand over to our coordinator, sir, Professor Subroto, sir, for carrying forward the session. Thank you all.
Okay, thank you all. The second session will be delivered by Professor Dr.